Let's look at the question of 46, the second sub-question. This question is find Fourier transform of pi t minus 3 and plus pi t plus 3. In this question is to practice the time shifting property of Fourier transform. This is a time shifting property. Xt minus t naught time shifted. Then with a Fourier transform, the Fourier transform is shifted by the phase e to the power minus j 2 pi ft naught. That's a phase shift. We know Fourier transform pi of t. Fourier transform pi of t, that's sinc f. So using the Fourier transform property, this is phase shift, and this is a phase shift. And then you organize a little bit, take out the sinc function here, and using Euler's formula, that's cosine, double the cosine, right? Next is we want to find out the Fourier transform of 4 pi t divided by 4 and cosine. So this question practice two properties, scaling property and modulation property. So scaling property, that's here, Fourier transform. The modulation property, this is the modulation property for x of t multiplied by cosine 2 pi f naught t, that equals to the spectrum of Ex shifted to f naught and shifted to the minus f naught, sum them up, divided by 2. So this is a modulation property. Now let's obtain the Fourier transform of this portion. First of all, let's use the scaling property. Fourier transform pi t divided by 4, that equals to 4, and think 4f. And then there's scalar at the front, 4, and then 4 and 4, that's 16. Then we use modulation property, place the f here, x f with f minus f naught, with you replace f with f minus f naught and f plus f naught, and sum them up, divided by 2, and 16 become 8 here. Next question is to obtain the Fourier transform t sinc t. In this here, we need to use the definition of sinc t. So sinc t equals to sine pi of t divided by pi of t. So you plug it in, that equals to, take Fourier transform this, that equals Fourier transform 1 over pi, and Fourier transform pi of t. And this is a typical Fourier transform pair using the sine function. You plug it in, the frequency is half, so delta f plus half and delta f minus half, and there's a j there in the formula. Next question, obtain the Fourier transform of x1t equals minus xt, all of this. And we organize a little bit here, take out minus xt and xt here, and that equals to xt cosine 2000 pi t plus xt cosine 6000 pi t now. So now using the modulation property here, taking out, this is the first portion, this the frequency of this cosine is equals to 1000, and the frequency of this cosine equals to 3000. That's hertz. Okay. And using the modulation property, that equals to that. If we draw that, suppose this is a spectrum of EXF. Here the magnitude is 4 at this high point. And then you plug it in, this spectrum move up to 1000, that's here. As this term move up to 1000, and this spectrum move up to minus 1000, that's minus 1000. And this spectrum move up to 3000, that's here, and then move up to negative 3000 here, and you sum them up, you divide by 2, the magnitude becomes 2. Let's look at question 49. 49 give us a lot of waveforms in time domain, and then ask us to find the Fourier transform. To find the Fourier transform, first of all, we need to find the expression of time domain functions. Let's look at just this one first. This one you can see here is a linear function because those are straight lines. Those are linear functions. And without guessing, without knowing anything, we can use a general strategy here. A straight line, we know that can be expressed by y equals to ax plus b, right? Okay, and so when x equals to -1 here, y equals 0, and then you plug it in, x equals to -1, a multiplied by -1 plus b equals 0. Second point, that's this point. That's this point, this point. When x equals 0, y equals 1. So we have y x equals 0, that equals to 1. That equals to a multiplied by 0 plus b, that equals 0. You solve these two equations, we have b equals to 1, a equals to 1. So what is this waveform? This waveform is t plus 1. At where? At t from -1 to 0. And this is a definition of Fourier transform. So this question is to practice the basic definition of Fourier transform. You plug it, then you plug it in. T is, and in this case, the rest of here are 0. You only have values from -1 to 0 and 0 to 1. You have to have two segments because this two segments has different functions, different waveforms. Now this is the first waveform, t plus 1, from t equals to -1 to 1. You do integral here. And then we do the same token from 0, t from 0 to 1. That equals t minus 1. And this is the two integrals we need to evaluate. This is a Fourier transform of xt. Now, how to handle this Fourier transform? We want to use some of our formulas. This formula we're going to use like x e to the power ax, you do integral, that equals to that. And we know this this is two typical integrals we want to know because we use a lot. Now you plug in, so this is a t multiplied by e to the power j to f naught, that's this term. You do definite integral from -1 to 0. And this term 1 multiplied by e to the power minus j to pi f t, as you integral as here. And then you do the same thing here, t e to the power minus j here, and then you do the integral and you, after you plug it in, do a little reorganization, this is the final result. Now let's look at part A. Part A, apparently we can do this. Y equals ax plus b, and you found the coefficient because this portion is a straight line. This is portion is straight line here too. So what we're going to integrate, we integrate from -2 to 0 and 2 to 0 to 2. You do two segments here. But there are better ways here using the pi function, rectangular function, and triangular function here. Here, if we recognize, I draw that. This waveform in the yellow highlighted here, this is actually 2 pi t divided by 4. So if we obtain 2 pi t divided by 4, that's this waveform, right? And then now, this is a triangular waveform. We know this is a lambda of t. This is a 1 minus 1 and t. What about if I obtain lambda t divided by 2? Excuse me for the, that will be -2 and 2. This is a 1, right? So this will be t here. It will be lambda t divided by 2. What about if I multiply by 2? So here that will be 2 here. Now if I take the difference, this yellow highlighted minus this, that's this waveform. That's this waveform we obtain here. That's this one. So therefore, if we know the time domain function is this, Fourier transform pi t, that's sinc t, and then using scaling functions and everything, is very easy to obtain the Fourier transform. And for part B, let's look at the waveform. So this is a practice, the basic functions, basic signals here. And if we look at this, what is this? This is the same thing. This is the same double of pi t divided by 4, right? So now this portion look like reciprocal of lambda t, triangular. So if we minus of that, this we will obtain this waveform. We will obtain this waveform here. If I take 2 pi t divided by 4 and minus this rectangular, we will get this. And this does not change because this only has from values from -1 to 1, rest of 0, right? So therefore, from -2 to 1 here, that's still 2. And here you have the difference. And then once we obtain that, it's very easy to obtain the Fourier transform. So that's this question.